So, greetings everyone from Baden-Baden, Germany, our headquarters for Schöck. I hope you had a good time so far with my colleagues, with lots of interesting topics and some discussions as well. So let's close the day with our Schöck Scalix dimensioning software. So my name is Stefan Puchstein. I'm product manager digital services for Schöck. So I'm responsible for our dimensioning software and design software. In the next, I would say, more or less 1 hour, I will share you all the insights you need to use Scalix in the future if you haven't done so far. So let's see what our topics are for today. The agenda. Firstly, I want to introduce you into Scalix. So what is Schöck Scalix and how to get you started and project management in Schöck Scalix in our new Scalix framework. After that, we have a more or less full view into the module expansion joint to dimension our Schöck Stacon shear dowels. After that, we'll have a look into our module for balconies for our Schöck Isocorp elements. And finally, we have a quick look at our additional Isocorp desktop software, which we provide to you. So we start. What is Schöck Scalix? Schöck Scalix is a modular software we've developed for dimensioning our Schöck products. Modular means it's providing a framework which you can use as a web tool. So you can use it in your internet browser without any downloads, any installation, any delays. So you have to wait maybe for your IT department to install any new updates. So you're always up to date with our latest product portfolio. And you're sure to have all the latest features. You don't have to worry about any other topics. And to use it, of course, it's free of charge for all of you. So you have to register. And the website is scalix.schöck.com. After that, it's free for use for all your time, and you can be happy to use it. What are the available modules? As I said, it's a modular software. For now, we have 3 different modules available. The first module is our module expansion joints, which can provide you with the dimensioning of our Schöck Stacon shear dowels, type SLD and type LD shear dowels. We'll have a look into that in the next minutes. And after that, we have a look into the module balcony for reinforced concrete, to reinforce concrete slab connections. And finally, we would have a module for our 60 type A elements, but that's out of topic today since we don't want to have a look into that for today. It will crash our time frame, so we'll have a look into the module expansion joint and module balcony. What should I say about that? The expansion joint is already available for project location Estonia, which means, of course, all the partial safety factors, all the product range we provide you for Estonian market is already available. For the balcony, we are not that far for the moment. You have to select the project location Germany, but we can provide you with an Estonian version of that in the near future. But for the moment, we have the project location Germany to dimension any Isocorp elements in Scalix. So let's get you started with the project management. In the next minutes, we'll have a look into the software itself. We'll have a look how you create a project, enter all the project information you need. And after that, you can even adjust that information. We, of course, show you how you can export your project to save it locally on your own hard drive or network system. And of course, you can import projects as well. And I'll show you how to do that right now. So here we are in the user interface of our Schöck Scalix software. If you start it, it automatically starts with this view, and you can enter a project name for a new project. After that, you can select any of the building project location. As I said, Estonia is also available, but not for any module, but we'll start with that and change it later on. You can type a project number, your project manager name, and some description if you want to create the project. After that, you are in the position view. You have the possibility to load and export projects here. We'll go to that later. Or you can select a module for a new position. In this case, we selected the expansion joint module and give that position a name. You can create that position, and here it is. After that, you can work with that position, or you can change your project information. We added it for the moment. We changed the location, as I said, from Estonia to Germany in this moment to have all the modules available. I'm gonna pause here, or sorry, that was a mistake. I don't want it to quit the video. We go back to that again. I wanted to go, we're already in Germany. Yeah, pause the video right here. Since this very important information, if you change the project location, all the results will be reset. So if you have any calculation results, it will be deleted for the moment. But of course, all your input data is still available. Why do we have to delete the results? Because, of course, regarding the building location, some partial safety factors might change, so the results won't be the same, or the product range isn't the same for all the countries. Schöck provides different product portfolios, maybe for different markets. So it's important that we, first of all, delete the results, but of course, all the input data is still available. So let's go on. What we might do as well is we can add another position. In this case, we had a position for expansion joints. Let's create a position. Okay, this one's for expansion joint as well, but maybe for isocorp for the balcony as well. What you can do now is you can also copy positions, delete them, or move them up or down to have your own sorting in the position tab. You can name those again, maybe with another number for your next position. As I said, you can delete those as well. So the next topic, of course, is how to export your project. You just click the export button and it automatically saves a .bem file to your local hard drive under your downloads folder of your browser. You can, after that, of course, give that project your own name and choose a location where you want to save your data into your network system or on your hard drive. If we start again, we just refresh the site, start from a new project. You, of course, can import the project again. So we just have to select that .bem file. And yeah, here we are. We have all the information we already did again, and you can work on with your project. Another topic, which is quite a success for us, I would say, since we are web-based, we of course can provide you with different versions of the software itself. So if you load an older project file, you're gonna be welcomed with our migration wizard, and you can choose after that if you want to process your project file in the original program version where you exported it. And of course, then you still have all the design results and all the input data. Or alternatively, you can choose that you want to use the current program versions and use all the new program features. And of course, maybe the newest product portfolio as well. We'll have a look at that again. So we load an import a project file. In this case, it's an older project file, as we can see. That's the new wizard, the migration wizard. The module in this case is the concrete balcony module, and the project file was saved as 1.11. The current version is 1.13, so there's a new version available. So now you can choose to use the original version, or if the checkbox is selected, you can migrate those positions to the newest versions. You can, of course, inform yourself about any new releases, any new functions, bug fixing, and the release notes tabs. So you can decide after that if you want to use the old version or you want to migrate it to the newest version. For now, we use the old version. We have both positions which are already designed in the past. Here again, as you can see, the module version in this case is 1.11, so the original module version. As you can see, that's a quick look into the isocorp module, but we'll have a deeper look into that in some minutes. The results were there as well. So let's start again. Open a new tab or refresh the page, load the project again to reload the migration wizard, but in this time we migrate to the newest version. If we open that position, we can see, okay, we don't have any results yet. It's graying, so we can click on the tab, and the project version is the 1.13 version, so you're on the latest version for our isocorp module. That's the options you have working on older project files. So let's go on and let's have a look into the expansion joint module. By default, of course, you have two different options to dimension our Schöck stack-on dowels. You, of course, can use our technical information, which will provide you with all the data you need, with all the load capacities and geometric boundaries to use the product itself. Or, of course, you can use our Scalix module, which will help you in all the process and which will guide you through the whole dimensioning of the Schöck dowels. What type of installation solutions or situations we can provide you in the Scalix software? So we have four different kind of slab connections. The slab is always the part which will provide the load and is supported, for instance, by a wall, by a downward beam, by another slab, which is indirectly supported, or by a slab which is directly supported by a wall, for instance. And then, of course, we have three different face-sided connections, which are face-sided connections between downstand beams between walls, or wall-to-wall connections. So let's have a look how the geometric data and the reinforcement input has to be done into the software itself. So first we have to choose a connection type, which we have seen, one of the 7 connection types we've seen, and we switch around the left and the right part. So you can choose if the view is for the left or the right part. You can see it in some minutes in the software itself. And then, of course, you have to enter the planned and maximum joint width. So, of course, the expansion joint, which is provided on the construction side, is the planned width. But you have to type in the maximum joint width, which can be done because of thermal deflection of the slabs. So if the joint opens because of thermal deflections, of course, that's the necessary information we have to use for our dimensioning of the bendings of the shear dowels. Then, of course, you have to enter the geometry for all the parts. You can choose if you have a height offset or off-center dowel position. You can choose the materials for the dowels and the sleeves, of course, for the concrete and the reinforcement steel as well. And you can choose if you want to automatically determine your reinforcement or if you want to set it manually according to your requirements. Let's have a look into the software to input all the data. So first, on the right side, you have the graphic view, and on the left side, you have 4 different tabs, which will guide you through all the inputs. We start with the installation situation. And on the right side in the graphic user interface, you can scroll down so you can see the design load and other information as well. But we start with the situation. In this case, we want to calculate a slab directly supported to another slab. But as you can see, you have all the different connections types here to choose from. We start with the directly supported slab. After that, you can see on the right side, the graphic interface might change. You have the top view. On the top side, you have the side view of the expansion joint and the front and back view of the slab to your left and to your right. At first, you have to, of course, select your joint length. In this case, we do it by 7,500 millimeters, so 7.5 meters. You can choose if you have any requirements regarding fire protection. So in this case, we provide our additional items here. Then, of course, as I said, you have to choose your plant joint width, which will be down on the construction side, and your maximum joint width under thermal deflection. And in this case, we select 50 millimeters for that. And yeah. Then after that, you can select your height offset or your off-center dowel positions. We'll come back to that later. And of course, your material for your steel, for the dowels and for the sleeves as well. In this case, we use stainless steel for the dowels and for the sleeves. You can choose if the sleeve part is on your left or in your right connection part. In this case, we choose the left part. The next input you have to choose is, of course, all the geometry necessary for the slab. So you can choose that we can use the left-handed structural component for the moment, which will be a slab thickness of 300 millimeters. You can choose your concrete cover on the top, on the bottom, and then the front of this part. We'll stay here with 30 millimeters for all the concrete covers. Then, of course, you have to choose your concrete grade for the concrete part and the reinforcement steel. Then we go on to the right-sided part. We can enter here some more information. In this case, we leave it like that. We can choose if we want a height offset. Height offset now means the upper side of the parts are on the same level. If we choose to have a height offset, in this case 50 millimeters, the right part goes down, and you have individual flexible situations, connections you can calculate. Off-center means the dowel isn't centered in the middle of the right or the load-providing part, so it might make sense to have a different level for your dowel in some situations. In this case, we leave it in the middle of the right part. So we go on to reinforcement. As I said, you can choose to do it automatically, or if you uncheck that toggle button, you can choose your manual reinforcement for the slab on the left side, which is the supported slab in this case. So the longitudinal bars, and for the right side, of course, which are bars as well as and some all the different reinforcement. In this case, we stay with the automatical reinforcement, which will provide you with a economical solution and helps you with your calculation. After that, we have to go on and provide the system with our loads and, of course, some additional informations. So what you have to enter here for your loads is the design shear forces VED along the joint. So we have to calculate those shear forces on design level, as I said, by yourself in your FEA software, or however you want to calculate them. After that, you input the data here in the software, and it will calculate the shear forces for all the dowels that are used in the calculation phase. Of course, you can choose if the number of dowels is chosen automatically, or you can alternatively choose a manual dowel spacing between all your dowels. After that, you can also select whether you want or have to use transversally movable dowels. So that means the dowel itself is not only longitudinal movable, I would say, but also along the joint, which is necessary if you have very long joint widths. I would say more or less 8 meters plus, and you have some thermal deflection along the joint as well. But we'll have a look at that as well in the software right now. So we start with the load input. You can choose between a constant load, linear loads, or a free input. If we scroll down here, you can see the design loads that you have input here. We start with 30 kilonewton per meter as a constant load. You can, of course, override that or use a linear curve, for instance, from 30 to 50 kilonewton on the outside of the joints. Or if for free input, you can choose the length of different sections for the loads. In this case, we start with a length of 2 meters, and we try to emulate some sort of stiffening effect because of outside walls, so which means maybe the load on the outside is a bit higher than in the middle of the joint. And we start with 50 kilonewton, go back to 30 kilonewton, and after that we have a constant part with 30 kilonewton in our example here, and go back to 50 kilonewton on the other side of the joint. But you are very flexible to try to remodel the shear forces, which are the result of your FEA calculation. Some other inputs are, as I said, you can choose to determine the number of dowels automatically, which is my preferred solution, or you can, of course, select your individual dowel spacings if you want to do so. We stay with the automatical algorithm here. And as I said, you can use the transversal movable dowels, which makes sense to use them on the outside of your joints. You can start from the left here. I select here a length of 1.5 meters, 1,500 millimeters on the left side, 1.5 meters on the other side, which means the type Q elements for transversal dowels will be used here. And then there's another checkbox which you have to choose if you have outside parts which are under even bigger thermal conditions. So we have to bring back our load capacities. So the next step is, of course, to calculate your results, start the calculation, and of course, check the status of your results and select the solution. You will see in a minute that we provide you in the module expansion joint with different solutions, and you can choose any of those solutions which are totally fine in the status. Of course, you can check your individual static proofs to check for your required reinforcement. And after that, you can export your log file as a PDF file for your selected solutions. So let's have a look at that. So to start your calculation, just click on the button on the upside of our toolbar, and you automatically go to the calculation tab. You can go back to your system tab if you want to see any updates you make on your geometry. On the calculation tab, you can see all your results. So you have a list of different solutions here with a ranking from 1 to X, I would say, with different product solutions and number of dowels pre-selected for you. And the upside, the highest ranked solution is totally the most economical solution. And you can check here if the status for all the static proofs and all the geometric proofs are okay. If so, there's the checkbox with the green check mark. If there are any errors because of static improvement, they are red, and you are provided with the red X here. So you can select any solution you want to use. You can go down here and check for the different solutions here. In this case, we only have 4 different dowels used. You can check for the static failure of the steel. And for the ultimate limit states, you can check the utilization of the different dowels as well. And yeah, that's it for now. And on the upper right, we provide you with additional information. And here you can also see if we use a solution which has some errors, it will light up here and it will get red. So you can obviously see that that's not a solution you should use, but you can of course have a look at that solution as well. On the left side here, we have all the information you need for your reinforcement. So all the positions are numbered, and you can use that for all your next planning steps for your drawings of the reinforcement. In this case, the highest ranked solution here has 11 dowels with less dowel spacing, but that's economically a better solution than our higher load stages here. In this case, I've selected a solution which has some errors. As you can see, the ultimate limit state, the outside dowels, position A, B, J, and K are above 100% utilization, so the static proofs aren't correct. So we go back to our highest ranked solution, in this case, which is 11 times LD30 or LDQ30 dowels. Or I'll go back here to the information tab. As you can see, if we select any solution with some errors, it's highlighted here in red. Okay, let's select the first solution again and export our log file. Take some seconds, and then we provide you with the PDF file with all the information you need for you or for your colleague who will maybe do the drawings, and get all the project information, all the geometric input data, all the loads, of course, all the positionings of the dowels, and of course, all the reinforcement as well, and all the position numbers, and of course, all the static proofs. Here in this case, they are all green, all checked, all fine. So that's a solution you can use for your calculation, for your project planning. Okay, that's it so far for the expansion joint module. Let's go on with the module for the balcony for the Schöck isocorp. One of the most important selections you can do in the beginning on the Schöck module for the balconies is you can choose geometry, standard geometry. We provide you with 4 different standard geometries, which is a rectangular form, a loggia form, which is some sort of 3-sided connection with an inner corner and outer corner. We'll come back to that geometries right now. After that, you can choose to have freeform geometries. So you can select that toggle button to use all your input data you've already done in the standard geometries, and have some sort of expert mode, I would say, where you can have even more flexibility regarding your geometry, but also regarding your load cases and so on. But what are the key differences between the standard and freeform? Because both of those situations have their advantages. Of course, you can work really quickly with one of those 4 standard geometries. You have to do some more work if you use the freeform geometry. So if it fits for you in your geometry, I would suggest to use the standard geometries. But you are more flexible on the freeform geometries. If you have to use more than 2 or 3 connection lines for your isocorp because of your different connections, connection types to walls or whatever, feel free to use the freeform modules in this sentence as well. The automatic determination of required structural behavior helps you to select you whether you have to use isocorp elements, which also provides you with bending moment capacity, or if it's only isocorp elements which are only providing you with shear force capacity. So for the standard geometry, we have an algorithm which helps you to select in which areas it's necessary to use bending moments or only shear moments. For the freeform, as it's an expert mode, you have to choose that by yourself. Earthquake verification and horizontal load is only available in the standard geometries, not in the freeform. Also, the check for vibrations is only available in standard geometry. Different load conditions for loggia only in standard. And yeah, the advantage in freeform, as we can see in the next minutes, is that you can select unlimited amount of different load level combinations and load stages as well. So my tip is to always start with the standard geometry, and if you have any boundaries after that, you can feel free to go on with the freeform, but it's a lot faster to use the standard geometry. So what are the geometries you can use in the standard geometries? For the rectangular modules, it's those boundaries. You can select a length A and a length B, which helps you provide you with all the data you need for the balcony. And you can select some overhangs on the left and on the right, as you can see highlighted here in red. If you want to do so, you can select to use some sort of supports, external supports, which have fixed positions, as you can see here. Of course, you can deselect all these supports to only use some of them or none of them. And I will go on with the loggia. It's quite the same. So you have two different lengths, length A and length B. You can select an overhang here, and of course supports. Again, for the inner corner, again, in this case, it's two lengths as well, length A, length B, with the overhangs left and right and the supports, which you can choose to use. And for the outer corner, you have to select 4 different lengths, A, B, C, and D. And you can use, again, different support locations if you want to do so. So let's start and have a look into the software again, and start with the standard geometry input parameters. So as I said, you have the 4 different geometries. On the left side, again, you choose all your inputs. And on the right side, you have the top view and the side view for your selected connection line. So all the input data is done in the left side window. And yeah, as you can see here, in this case, rectangular shape, we only had 1 connection line, but it depends on the standard geometry you have chosen. We start with the rectangular geometry. We don't use the freeform so far. We can select here our length A, and as you can see here, we validate the data, so you aren't able to use any data that isn't possible with our product in this case. You choose to do an overhang, deselect it, or you can, as I said, use supports. You can click on the supports to deselect them if you don't want to use those supports. In this case, we leave that 1 support here. Then you have to choose between different connection types, slab to slab, or if inside you only have a wall, to the up or to the down side, you can select those connection types as well. If you have any sort of height offset, you can do that here as well. So you have to select the different thickness of the inside floor. And you can choose here the height offset, same as in the expansion joint module here. Of course, you have to select the the width of the wall or the downside beam here as well. In this case, yeah, we leave it with 200 without any sort of height offset. After that, you can enter your connection line properties. In this case, we only have one connection line. But if you have any more connection lines, you have to select the connection line in the Dropbox here. Next information you can do is you can select sections where you don't want to have any sort of load capacity for the isocorp elements. For instance, if you have any sort of holes in your floor which will collide with our bars, you can select those elements, choose the spacing and the length of those sections. In this case, we position our isocorp type Z elements here, which is some sort of insulation without any sort of load capacity. Then after that, you select the material, the concrete grade for the floor or slab, and the structural behavior. As I said, you can choose in the standard geometry to use the automatic structural behavior, which will take into account the placement of our support, which make it easier for you to decide whether it's necessary to have some sort of bending moment. Of course, you can also select free type Z, but in this case, it will change and make an error because you won't have any sort of connection here in this case. After that, you can select the concrete cover for our elements, the element height, and you can choose if this connection line has some sort of alternative type of connection. So if you have more than one connection line, you can choose if some of those connection lines are only wall connections or if all of them are slab-to-slab connections. Then after that, you can choose the maximum utilization for the static proofs. Default value here is 90%, but of course you can go up to 100% here. Or you can choose if you want to increase or decrease the amount of different isocorp elements which should be positioned. I would start with automatic, which will make you the most economic solution. Isocorp model, of course, is necessary. And the toggle button here is for prefabricated elements. And the last input here is the concrete grade for the balcony slab. Then we go on with the load tab. For the standard geometries, it's quite simple. We provide you with different default values. Of course, the dead load of the concrete is calculated automatically. You can select different loads, constant loads for your finishes. You can select the edge load, so some sort of railings or parapet loads here. You can select if your railing is only in the front of the balcony or if it goes around the whole geometry. Your live loads, you can select if you have to use any sort of edge moment, so persons pushing against the railing, or if you have any sort of masonry or other line loads which are parallel to the connection line. You can choose the distance to the connection line and the load value here as well. But we go on with 0 for this. All the loads we've entered here are vertical loads. After that, you can choose to enter horizontal loads in two different directions, in the X and Y direction. If you have any sort of wind load, for example, you can do so, or you can also automatically calculate earthquake loads here, which will be then calculated by Eurocode. The manual product installation part, we'll skip that part for the moment. We'll come back to that later. So that's all the information we need to do a calculation in the next step as well. So, of course, we start the calculation in the next step. Then we can check our element placement on the results page. We can check our of course, our connection lines and especially our design loads, the shear forces and bending moments across all the connection lines. On the result page, we can check for errors and warnings, and we can manual swap isocorp elements, element by element or position by position. But we have a look at that as well. And of course, you can also export a log file as a PDF file here as well. So we start by pressing the calculate button again. Takes some seconds for our FE solver to do the magic, and we are on the result page. You can swap again to the input page if you have to do any changes to your system. The first part here is the top view again with the positioning of the elements, and to the right side you have the position list with all the isocorp that are selected here. So the red color means those are elements which only provide shear force transmission, and the blue elements provide you with moment, bending moment, and shear force. So as you can see on the left side, opposite to the support, it's only necessary to use shear force transmission here. If we go down here, we can choose our connection line. In this case, we only have one connection line, one design combination. We can check the bending moment here across our calculation, and it's calculated or located from node 3 to node 4. So in this case, node 3 is on the left side of the curve, node 4 is on the right side. So again, across the support, we don't need any shear forces, so we don't have any bending moment here, and the shear forces change directions. Across that or under that, we have all the different static proofs for all the positions. In this case, we have 4 different elements selected. We have all the utilizations for bending moments and for the shear forces. And of course, we can check the statuses here as well. In this case, it's all green, it's all fine. All the static proofs are under 100%, or in this case, under 90%, which was our maximum utilization chosen. Here, you can swap elements to use any different load stage if you want to do so in the process, and recalculate all the static proofs in this case. As you can see, you can do it right up there as well for all the positionings, in this case for number 2. We chosen the same load case with then in position number 1 and for position 2 as well. So we are left with 2 different element types in this instance, which might make it easier on the construction side, but of course isn't the most economical solution if you have to look at that. Here as well, you can have a look at all the information and all the warnings which will provide you here. Warnings aren't errors, so they provide you with additional information you might have to look up into your construction phase. So in this case, we manipulate our system, we delete our support, and the cantilever length is now 4 meters, which means, okay, our product range couldn't provide any sort of product for that because the load is too high. In this case, you can send the project file directly to Schöck, maybe to make our department, our structural design department, provide you with a special isocorp element. But of course, as highlighted here, we have some errors, and we can double check which the problem is. In this case, as you can see here, the utilization is above 100% for the bending moments. So we can provide you with a solution here with our standard products. And of course, as I said, you can export a log file, a PDF file as well. We do so by clicking on the export log, takes some seconds again. And after that, you have in this case, we exported a file with some errors, which will be clearly highlighted here as a watermark. So if we want to show it to some other engineer or some other responsible person in your project, you can provide those data as well, but it clearly highlighted that there are some errors and the system isn't statistically correct. At the end, we also provide you with some additional information about building physics, and yeah, so more or less all the information you need. So we go on. We've seen the geometric data we can select for the standard geometries, and we go on with the freeform geometries and with the input data that you can choose here. So at first, if you enter the mode, the freeform mode, you enter the freeform toggle button. All the geometric data which you have already selected in your standard geometry will be transferred. But you have, of course, different additional functions available via a toolbar in the software itself. We have a look at that, of course. All the node coordinates can be entered with millimeter precision here in tables, especially. And of course, you can add any additional connection lines, supports, walls, point loads, line loads, and place them wherever you want to do so. So we start with the standard geometry. In this case, it's the inner corner, as you can see, and choose to select the freeform. And we get additional information that you're swapping to the freeform mode, and you can do so, or you can cancel the process here. And now we are in the freeform mode. As you can see, we have two different connection lines. We have all the node coordinates in this case in table form. So you can, of course, change those coordinates here as well. But we have a look at the connection lines, connection line 1 and 2 in this case, and the structural behavior. Yeah, you can't choose the automatical solution here. So you have to choose if you have bending moment and shear forces, or if you only want to provide products with shear forces. You also see here the toolbar. With the select tool, you can move nodes, but you can also do that by typing in the coordinates in the table as well. Or you can do so by typing here the length of the connection line 2, in this case, leaning on from node number 4, 1.8 meters. And yeah, you can deselect it. You can make the changes again in the table form, or you can move the node again to come back to your default geometry. Of course, you can also move other nodes. In this case, node number 2, for instance. We can add nodes to our system, maybe inside of some outer lines or inside of our structure itself. And after that, you can move those nodes by table, or as we can see here, by the select tool. Next step maybe you want to do is to add a support. In this case, a punctual support. You can choose to do so wherever you want, or you can choose to have some line support, some walls. And if you add a new support, you can choose to have it infinitive stiff, or you can enter the stiffness value for the support itself. Of course, you can also do that by clicking on the line support, which will provide you with a wall, where you can also choose the stiffness value if you want to do so. In this case, we delete those information. We don't want to use the line support or the punctual support, but we want to have another line here and add the wall on this line. Maybe you can do so as well. It doesn't have to be the outside lines where you can place your line loads or your line supports. Okay, so we finalize our our module here, we can also add additional connection lines with isocorp elements. In this case, we had some loads here, which will be automatically deleted if we choose to have a connection line on this line here. And as you can see, you can also add the properties here and make some final stages, final changes to your system. Okay, so that's all you can do with the different geometry data, but also you can have different load cases in the freeform geometry. You can have any number of load cases. You can add additional line loads and point loads wherever you want, and you have the possibility to add customized design combinations, which also will affect, of course, the static proofs for our isocorp elements. So let's have a look at that as well. We still are in the freeform geometry. We have a line support here. We'll go down to our load part here. As you can see, it looks quite different than in the standard geometry. You have the different characteristic load assumptions, which will be automatically transferred from the standard geometry. The dead loads, the distribution loaded, which is also deselected, so you can change that, but the finishes can be changed here in this case, or if you click on the graphic interface as well. We can go on with the edge loads for the railing. You can, of course, change it here in the table or in the graphic interface as well. So if you want to have different railing loads per line, you can do so by selecting it in the graphic interface, or as I said, also in the table here. You can add, of course, new loads. For instance, if you want to use any type of snow loads, you can do so and select if it's permanent, variable, or the accidental load by the Euro code. This case, snow distributed load. I select 2 kilonewton per square meter here, and as you can see, it's automatically selected in the design combination for the ultimate limit state. We also have a serviceability limit state here, which provides you with the calculation for the deflection and the characteristic levels. For the ULS, snow is already selected. You can choose your partial safety factors and your combination factors regarding the Eurocode calculations. In this case, we add another design combination without snow deselected. So in this case, snow won't affect the load calculations here. Of course, you can also add any type of support loads if you want to do so. So we can have a look at different point loads, for example. Support loads from the upper floor, which will be transferred in our balcony geometry. In this case, we add another node here. We select it and place it in our geometry and add the point load symbol here. Just click the button and add your loads wherever you want. And it's automatically selected here in the ULS in all the new design combinations. So you have to unchoose it so you won't make any errors. And line loads as well, you can choose where you want to have those in your geometry as well. Okay, so let's finish our look into the isocorp module by having a look at the manual structural behavior. That's a feature which will provide you in the standard geometry and in the freeform geometry. It makes it possible to position your isocorp element very flexible wherever you want to do so. And you can also select the structural behavior of the different isocorp elements and the structural behavior. So a combination of shear and bending moments isocorp elements may also vary inside of one connection line here as well. 3 areas where you don't have chosen any sort of structural behavior were automatically filled with our type Z installation elements. So let's have a look at that. Here as you can see, we are in the standard geometry. We have a supported balcony with one support on the left side here, only one connection line. We choose to have the structural behavior of manual. At first, we don't have placed any sort of isocorp element, and the validation shows that there's an error. Of course, we have to make some sort of connection, otherwise it won't work in this case. So you can choose to have different sort of linear connections. For our 1 meter elements, you can choose to have the whole element placed or half the elements. For our QP elements, the punctual elements, you can have the different lengths. In this case, we select to choose one type QP element with 500 millimeters right across the support. And we want to have one type K element, which provides bending moment as well, with 1 meter, and 2 other type K elements, half elements with 500 millimeters are also placed here in the geometry. You can position it graphically here in the user interface, and to make it easier, you can select the type Z element, in this case with 500 millimeters, so you can place it here very exact. In this case, I've made a free section of 500 millimeters to show you that this is filled up with our type Z elements as well. So we have 1, 2, 3 different type K elements and 1 type QP element, and 3 different sections of our type Z elements for our installation elements. As you can see, position 2 and 3 are half elements with different load stages, so we can select to have the same load stage here, which will provide you with a much nicer, cleaner solution in this case. And with the manual structural behavior, it's possible for you to select if you want to have any sort of distribution load and to have any sort of spacing between different isocorp elements. So that's it for the module balcony. Let's have a final look at additional design software for the isocorp, which we will provide you as a download. I would say standard desktop software, which you can download at our Schöck.com website. So that's not a web-based software. It's a software you have to download and you have to update by yourself. But it provides you with 2 different features. One software provides you with the product range of our T and XT type SK and SQ elements. So those are the steel to concrete elements. As you can see down there, that's the software itself. It's a standard desktop application, which is running on all Windows PC. And the other option which will provide you for isocorp is, of course, our steel-to-steel elements, which is another software application. So you can choose to use all of them and download it by yourself on our website, Schöck.com. That's it. I'm done with my slides, with my presentation. I hope you've learned something about Scalix, and of course, I hope you try to use it in the future if you haven't done so far. Of course, we are always happy to get some feedback from our customers to use which really use our software and which will provide us with different ideas to make it even better in the future. Thank you for your attention.